Hi, my name is Mark Parrish. I represent Turpin Sales and Marketing, and this is section 5 of our presentations to try and help you in the metalworking industry. Today we're going to concentrate on how to recognize boring bars. So why are Turpin Sales and Marketing putting these presentations together? Well, the machining industry is facing a massive problem right now in lots of ways, but specifically in the shortage of skilled machinists. So we put together a series of presentations which are very basic, and they were developed with the intent to stimulate some interest from people who may want to come into this industry who've never considered it before. So who are Turpin Sales and Marketing? We're the leading manufacturer sales representative team in the metalworking industry in the Northeast. We represent superior products and have extensive knowledge in the metalworking industry that our customers have relied on for over 30 years. We have focused on cutting tools, work holding, tool holding, fluids for many industries: aerospace, firearms, medical and automotive. Through our technical expertise and selling skills, we provide the end user and distributor with increased productivity and profitability. This is achieved by assisting our distributors, end users, in presenting and implementing the quality products that we represent to the end user in a knowledgeable and professional manner. The metalworking industry is facing many challenges right now: supply chain, material availability, but I believe the biggest one we're facing is the skills gap. So what is the skills gap and what can we do about it? The skills gap is basically a shortage of skilled labor in the manufacturing and machining industry. No one's going to trade school. No one's doing apprenticeships. Skilled labor is very difficult to find. It's predicted that 3.5 million manufacturing jobs will be unfulfilled in the next decade, which will be devastating for this industry. So what can we all do to improve this situation? Do you have existing employees that have an interest in manufacturing? Maybe you hire a person with mechanical aptitude, good work ethic, but no manufacturing skills. So what's the solution? Train your own. So Turpin Sales and Marketing have put together a very basic series of training presentations to help to inspire people who may want to know more about this industry and help to bridge the skills gap. So what are boring bars? This slide shows you 3 typical boring bars that are a round shank, and they perform operations internally on the component. So on the ID, or internal diameter of a component, that can be turning, boring, threading, grooving, etc., but it is always on the internal or the ID of the component. As with turning tools described in our earlier presentations, boring bars conform to 2 standards: an ANSI standard, which is the American National Standards Institute, and is always done in inches. The ISO, or International Organization for Standardization, is the metric version of that. It's a series of letters and numbers which define the boring bar. So from that part number, you can work out exactly what that boring bar is, what its diameter is, what insert it carries, how long it is, etc. And I'll go through that in the next few slides. The first letter in the series, in this case it's showing an A, defines the type of boring bar. Is it a steel boring bar? Is it a carbide boring bar? Is it 6 times D? Is it 3 times D? Does it have through coolant? So you can see the one we selected here, which is A, is a solid steel bar with coolant through the middle, and it would up to 3 times D, which is 3 times its diameter. So that would be a 1-inch boring bar, would be 3 inches long. The next number on the ANSI 16, on the ISO 25 shown in this example, tells us the diameter of the boring bar. The ANSI and the ISO differ. In the ANSI, it is 16, which is equivalent of 16/16 or 1 inch. So that number is always in 16ths of an inch. If it's an 8, it's a 1/2 inch bar. If it's a 16, it's a 1 inch bar. The ISO is much more simple. It's in millimeters, so 25 millimeters It can be 40 millimeters, 32 millimeters, etc. But that's the easy one. 25 millimeters. The ANSI is 16/16, which is 1 inch. The next letter, in this case M, just describes the length of the boring bar. Again, ANSI and ISO differ. You can see if we look at the M, that would be 6 inches or 150 millimeters for the ISO. So really simple. Just look up the letter and it gives you the overall length of the boring bar. So far we've described the type of boring bar it is, the diameter of the boring bar, and the overall length of the boring bar. The next set of letters and numbers are based around the cutting information. So the next letter, in this case M, describes how the insert is held in the pocket. An M is a clamp and a pin. A C is a clamp only. A P is a lock pin and lever lock. W wedge lock, S screw down. I'm not going to go into those, but those are all standard ways of holding the insert in that the major manufacturers use. So again, look in the table, it will tell you how that insert is held into the pocket. The next letter, in this case a T, describes the shape of the insert. The ANSI and the ISO shape of the insert conforms throughout turning tools, inserts. Anything that complies to the ANSI and ISO standard will use the same letter to describe the shape of the insert. In our case, it's a T, which is a triangle. A C is an 80-degree diamond. I'm not going to go through all of these. A W is an 80-degree trigon. So this letter is the same letter on an insert. So if you look up, say, a CNMG, for instance, that C would stand for 80-degree diamond. This conforms across all ANSI ISO standards. The next letter, in this case an F, describes the angle that the insert is presented to the component at, or the cutting angle. So you can see that an F is a 90-degree end cutting angle. So you can see on the picture that's a square angle. And there are various different angles. K is 75, Q is 107.5, U is 93. So again, that letter describes the lead angle of the boring bar. Not particularly the lead angle of the insert, but it's the lead angle of the boring bar. The next letter, in this case an N, describes the insert relief angle. Again, this conforms to ANSI and ISO standard. So if you looked at a CNMG insert, the N would tell you that it's a 0-degree negative insert. The same applies to the boring bar. The B is 5 degrees, the P is 11-degree positive. So this will tell you the angle that the insert sits into that boring bar. The next letter is really easy. Left hand or right hand. In this particular item, we show an R, and you can see on the picture that is a right hand boring bar. Only two options, left and right. Really easy one. Well, that concludes our 5th section in the series of basic machining videos. So now with the boring bar nomenclature matching the insert nomenclature, you could work out what that boring bar looks like and which insert to pick that would fit into that pocket. So I hope you enjoyed it. We have more basic machining videos to come, but please visit www.turpinsales.com, or you can go onto our YouTube channel, which is under Turpin Sales. Thank you for listening.